Hey guys, so in this video we're going to start our study of physics by looking at motion and ways that we can describe motion. Now this video, for quite a few, if not all of you, might seem a little simple, a little straightforward, but we got to start somewhere, right? And so let's start at the beginning, and we're going to look at motion first in this course because, I think motion, it's easy to see, right? We're familiar with it, we move, we're in cars, we notice motion all around us. So we're going to start by looking at how things move. And historically, this is kind of how physicists started as well. They wondered about the motion of objects. They wondered about the motion of planets. They wondered about the motion of things that fall. So anyway, so we're going to start with motion and how we describe this motion. And when we look at motion, we have a couple of concepts that we use. And the first one, probably the most fundamental one, is this concept of position. And so position, very simply, the position of the object is where it is in space. Okay, so where the object is in space. So you can imagine, let's see, I have the ground here. Just pretend like that's a flat ground. And I have a ball, right? So I have a ball and it's rolling along. So I'm going to do like little speed lines. So it's moving in this direction. Okay, and then at some time later, it's going to be over here, right? And what we do is we want to describe where the ball is in space. And so position is where an object is in three-dimensional space. Now we're not really going to look at three dimensions. We're going to just do two dimensions. Two dimensions, remember, is like just back and forth, right? It can go left and it can go right. This isn't dimension, this is one dimension. So this can go left and right. Later on in the course, we will look at two dimensions. We won't look at three dimensions in this course. So for this one-dimensional example, we're just going to go from over here over to the right, and we'll define position. Now the cool thing is we can define our position to be wherever we want, right? We can make 0 be wherever we want. So just to help us, we're going to say that it's going to start off at 0 meters, and then it's going to move, and we're going to measure this, right? And just for funsies, we'll say that this is 10 meters, right? So we're going to start at this position of 0 meters, and it's going to end at 10 meters. Now, in physics, we like to assign variables to things, which, and for reasons which will become obvious pretty soon. So I'm going to say that this is x. So we use x a lot for position. So when you see an x in physics, very often that corresponds to position, right? And I'm going to say additionally that this is x initial. Now very often we just write an I here, but I'll spell this out. So this is x initial. This is the initial position of this ball. Then over here, I draw it over here. I'm going to make this x, but I'm going to say that this is x final. Okay, so we have an x initial and we have an x final. And so with this is one way to describe motion, right? It had a change of position. It went from 0 meters to 10 meters. Okay, and that's all well and good, and it does give us information, but there's more, right? And we know there's more. And so another thing that we can do, I don't think I get the same color. Let's do kind of here. Okay, so the other thing that we can define is something called speed. Okay, so we can define something called speed, right? So with speed, this is where we're going to start getting the math. Now, physics uses a lot of math. Okay, you're going to notice this in this course. So what we're going to say is there's this thing called speed. And according to physics, we're going to define speed as a change in position over the time it takes. That's not a T. We use t for time. So over the time it takes for that position to change. Okay, and we call this speed. And for reasons which we'll talk about later, we don't like to write out words, right? So we'll just call this v. Okay, and I'll let you guess why we call speed v. Okay, so v corresponds in this case to speed. This delta symbol, I'm not sure if you guys are familiar with the delta symbol, but when you see a little triangle, what this indicates is change in. Okay, so the little triangle means change in, and so a change in will always be the final thing minus the initial thing. Okay, so whenever you see a delta in front of something, what they really mean is there's this subtraction going on. Okay, so we can understand this speed v as being the final position minus the initial position over the final time minus the initial time. Okay, that's how we would calculate the speed v, is we would take the change in position over the change in time. And so the question we have is, what is the change in time? Okay, what is the change in time? Now very often you'll be given this to you. Okay, so in time. You'll be provided with the change in time in a problem, but again, just for funsies, let's say that this is 5 seconds, right, for this problem. So it takes 5 seconds to undergo this change of position. So then what we could do is we could say, okay, v, I'm going to go like into the gritty detail here, so bear with me. V is 10 meters, which is my final position, minus 0 meters, which I made my initial position, divided by 2 seconds, which is our final time, and we decided that we're going to make our start 0 seconds. Again, that is up to us. Okay, and so we do this and we get 10 meters, always include your units, 2 seconds. Okay, and so we combine that together and we get 5 meters per second as our speed, which you guys probably knew as soon as I told you that it was 2 seconds. But that's okay, like I said, we're starting slow here. So 5 meters per second will be the speed. So speed has this unit of position over time. Okay, and so for this one we get 5 meters per second. Now the reason why physicists like to use equations is for the following reason. It's great to know what the speed is, but with this equation we can also calculate for position, we can also calculate for time. So let's start with this nice little equation here. V is equal to change in position over change in time. This is our equation, and honestly guys, you should memorize this. Okay, make sure you memorize what all these mean, you know, not just the letters. So there's our equation. But let's say that we know the speed, and we know that, and we say that we know the time. And our question is, what is delta x? Okay, and that's kind of a nerdy, geeky way to ask, how far did it go? So how far did it go? Okay, that's the question we have. So what we can do is we can start with this equation. Okay, and we can use math and we can answer that question. So I like drawing x's apparently. Let's draw t. So what I can do is I can take this and I can say, okay, there's my equation, and what I'm going to do is I'm going to multiply both sides by delta t. Okay, so I'm going to multiply this side by delta t, and I'm going to multiply this side by delta t. And in algebra you learned that if you do this, okay, as long as you do the same thing to both sides, you're all good. And this delta t cancels out with this one, and we're left with one over here. So we get this equation that if I know how much time has passed, and I know what the speed is, and I multiply those two together, that's going to give me my change in position. Okay, maybe what we know, maybe we know the speed and the position, right? So maybe we know the speed and the change in position. And what we want to know is what is delta t. So how much time has passed? How much time did it take to accomplish that change in position? Okay, so maybe that's the question we have instead. And so what we can do is I'm going to start with this equation that we had right here. So we got this little one right there. So I'm going to say that delta t times v is equal to delta x. Okay, and let me move this up a little bit. And so that's going to be delta x. And then what I'm going to do is I'm going to divide both sides by my speed v. Okay, so again, as long as I'm doing the same thing to both sides, we're cool. And I cross out the v, and I'm going to get that the change in time is equal to delta x over v, because this v doesn't cancel out, right? So this is another equation. Okay, so from this, I could calculate the speed if I know the change in position and the time. Or I could do a little bit of algebra, and I could get another equation that allows me to get the change in position if I know what the time and speed is. Or, again, using a little bit more algebra, I can get another equation that allows me to figure out the time if I know the change in position or the velocity. So this gives you just a basic, very introductory idea of how physicists do things, right? We like to use equations because they're short and they show relationships between different quantities. That's what equations do in physics. Math is a tool that we use, okay, to find new relationships. So you're going to come across quite a bit of math in physics, but it's it serves a purpose. You're trying to learn something about what just happened, or you're trying to predict the future, which I think is just awesome. You're trying to predict the future and what will happen as time goes on. Okay, and that's kind of like the power of physics. So thank you for watching this video. Let me know if you have any questions, and in class we will start looking at motion, the measurements you take, and we'll look at graphs, and then we'll look at how we can solve problems in motion over the next couple classes. So again, if you have any questions, please let me know.